So for question 21, so start from the beginning of the question. They say state the zero of px. So you want to get zeros, means we have to get it factor first. As long as the value is a factor, means that as long as we can factorize, means, okay, let's say we can factorize x plus a, x minus b. So x equals to a, x equals to b, we call it roots. This is how we use our mathematical terms. In bracket, we call it that is a factors. So how about zeros? Zeros is a value. A, B, we call it zeros. So this is the difference term we use in this topic. The things is similar, but the grammar we use here will be different. So when you say you want to find out the zeros for this px, okay, so 0 we have to find out from our factors. So we take this px equals to x squared minus 4. So we try to factorize it first. So it will be x plus 2, x minus 2. So now this is in factors. This polynomial px is in factors. Then they ask for roots, means we will take out the value. What's the value? The value here is negative 2, 2. So this is what we call zeros. So of course, they didn't ask here is when we write x negative 2, x equals to 2, this is what we call roots. So different form, we will use different terms. In bracket form, we call it factors. In x form, we call it roots. So just the value, we call it zeros. Okay, so just 2 marks. So this 2 mark is on your factorize to get out the zeros. So without writing the x. So if you write x together, that will be wrong, because if you write x together, we call it roots. It's not called zeros. And then question B, they ask us, they say, when qx is divided by px, and then the remainder is 14x plus 52. So it got remainder. When it got remainder means it is a remainder theorem. So find the value of alpha beta. So we have two unknown to find, means we have to build up two equations. So the two equation, how we get it? When we say divided by px. Px here we got two value of zeros. We got two value of x here, where x equals to negative 2. Another x is x equals to 2. This is our divisor. This is our divisor px. So our divisor px here is quadratic. So we have two values. And say when this qx divide by this px, we get remainder. So means that when I substitute p negative 2, I get remainder 14x plus 52. So substitute into qx. So they use qx, so I follow qx. So I didn't use px because px is already for this quadratic polynomial. So for another x value here means I substitute this x into the polynomial qx. Same also, I will get remainder 14x plus 52. So after writing this theorem, so this is our theorem. After writing this theorem, then we start to proceed our concept. We will substitute negative 2 inside this qx. So it will become 16 alpha, then negative 2 cube, it give you minus 8. Then 2 square, 4 times 6 will become positive 8. Then 2 negative 2 beta plus 28 equals to, so here also got x, 14x. So we substitute negative 2, it will become negative 28 plus 52. It should give us 24. So I simplify this equation. Okay, so I will let it like this. Then our second equation will come from second information, second roots here, x equals to 2. So substitute 2 inside, 16 alpha. Here will be minus 8, then plus 8, or plus 8, plus 8 again. Then substitute this 2 equals to 14x plus 52, right? So here got x. Substitute 2 here, 28. 28 plus 52, 80. So simplify this. Simplify this, we will get 16 alpha plus 2 beta equals to 36. So we will start doing our simultaneous equation. You notice that what do we have? We can eliminate alpha because of 16 alpha they are same. Or we can eliminate beta also. So either one. Okay, so if I want to eliminate alpha here, I will take 2 minus 1, so that 2 beta minus negative will become positive. Then 40. So beta is 10. Then we substitute either one. Substitute into 2. So alpha is 1. So therefore, alpha is 1, beta is 10. So this is how we use our theorem to solve the simultaneous equation to find out alpha and beta. So same we can go here. You can see this is a concept, how we apply our reminder theorem and form our simultaneous equation. So we have two simultaneous equations, so same concept here. Reminder theorem. So both equations come from same concept. Then solving our simultaneous to get to the answer. So this is how we score these 5 marks. So we can see this one 6.21c. That's you about 6.1 concept. What's your 6.1 concept? Means we have to know our writing of division. When polynomial divide with your divisor, your equals to quotient plus remainder over our divisor. So this is our writing concept in our long division. Or another form is this. Px is equals to qx dx plus rx. So we have two forms. Normally, when we're doing factorization, that will be this form because this is one factor, this is another factor, and then we don't have reminder. So at the back here, 0. So you can see here, this is the pattern. Actually, it will be our divisor, it will be our quotient, and then at the back here is 0. So in the factorized form, normally we write in this. So division form, if you have reminder, we write in this. So using your alpha and beta in 5b. In this question B, find your reminder when your polynomial is times 2 and plus x divide with the same divisor px. Okay, so we get our polynomial first. Our polynomial by using our alpha beta, we complete our alpha beta. Our polynomial here is alpha is 1, so x4, then plus x cubed then plus 2x squared, then beta 10x plus 28. So this is our polynomial. And our divisor is our px. Divisor is our px because divided by px. So how we supposed to write it? So it will be qx divided by our divisor px. So it will get you a quotient qx. So I didn't write back qx because qx labeling already used, px labeling already used. So we don't do it double so that we didn't confuse which qx that it means here. So I will write it in quotient, the full sentence here, quotient, plus when you divide by px, our first result from b here, they said remainder is 14x plus 52. So 14x plus 52. This is what we get from our question B. This is what we get our question B, where polynomial qx divided by divisor px, our remainder is 14x plus 52, and we find out what is our alpha beta. Okay, so this is our writing on our division. So I can write it in the equation forms, not in the fraction form. So means that my qx, it will be equals to the quotient times our divisor, and then plus 14x plus 52. So you can see our polynomial is qx, our quotient we don't know, but our divisor we know is px, and our remainder here is 14x plus 2. So we proceed for part C here. They say you have to find the remainder, means I have to find this remainder. What is the remainder? When our polynomial already times 2 and plus x divided by divisor px. So when this polynomial times 2 and plus x, when this polynomial times 2 and plus x, so means the whole equation will be times 2 and plus x, times 2 and plus x. So this part, because it is a equivalent, right? So this whole part also will go into times 2 and plus x. So you will equals to 2 quotient px, and then this times 2 will become 28, and then this times 2 will become 104 plus x. So we simplify here. You will getting 29. So you can see clearly we still have same divisor when this 2qx plus x divide by this px. Of course the quotient will be different already before compared with the original polynomial before this. And then our remainder is this part. So we can read out our remainder here is equal to 29x plus 104. So this part is testing you on 6.1. Do you understand the writing form of division or not? Polynomial division. So from here, we see the first concept is this. Writing our polynomial, what is your quotient, what is your divisor equals to your remainder. And then we start working out times 2 and plus x. Times 2 and plus x. And then to get to this answer and read out this is the remainder part.